Okay, I'm making a video for single displacement reactions, which are also called single replacement reactions. And in this lab, we are combining metals in 6 test tubes with different solutions. So in the first test tube, you can see it's copper and silver nitrate. In the next, we have lead and copper 2 nitrate. In the third, we have zinc and lead 2 nitrate. In the fourth, we have zinc and magnesium nitrate. And in the fifth, we have copper and sulfuric acid, which is hydrogen sulfate. And in the sixth, we have zinc plus sulfuric acid or hydrogen sulfate. Now, in single replacement reactions, the only way this reaction is going to take place is if the metal that is by itself initially is more reactive than this first substance here. In this case, it's going to be a metal or either hydrogen. So if the reaction takes place, if we put copper and silver nitrate in a test tube and we see something, then we can say, yep, copper is more reactive than silver. But if we put these things in a test tube and nothing happens at all, then we can say copper didn't have the reactivity to make this reaction go. So we would have to say silver is more reactive than copper. So the goal is to look at these 6 reactions and then rank each of the metals or the metal and the hydrogen according to greater reactivity. So I have some test tubes set up here, and if you just take a look at the metals first, copper is an orange shiny color, lead is kind of a bluish gray, zinc is a shiny metal, and then we have the zinc and the copper and the zinc again. So I'm going to place each of these. This is probably not the best quality. Each of these in a test tube. I'm trying to find the best view of this. And maybe if I get closer, that camera will take over. It is not, it's very difficult. You can see that the copper is starting to get coated with something. And there's definitely something happening. That copper is starting to get coated with something. And I put this one in a little while ago. And you can see there are bright, shiny crystals, and also the solution, which was originally clear, is starting to take on a bluish color. So this is the copper and the silver nitrate producing these little crystals. Now it's up to you to figure out what the crystals are, what's making the solution blue, and which element is more reactive. Is the copper more reactive than the silver, or is the silver more reactive than the copper? All right, with the next one, we have some lead in copper nitrate. And initially, you will see it turned black right away. It is coated in black. I will let you look at this one. It's been in there for a while. It's black. If I dislodge it, you might be able to see some little particles floating in there. I will show you this one, which has been sitting for quite some time. You can see that the solid in there has kind of taken on a reddish color, and the solution has become less blue. So this is the lead with the copper nitrate. All right, the next one is zinc with lead nitrate. And I think right away you can see that it turned a dark color. I want to get the best view of this that I can. It turned a dark color. There are little shiny things forming on that. And let's just take a look at this one. If you look in there, there are little shiny crystals that are now forming on that piece of zinc that was there. So something is definitely happening. I switch this around, you can see how beautiful they are. So what are those crystals? What are they made out of? Okay, and the next one is some zinc and magnesium oxide. And then I have some copper and sulfuric acid. And then I have some zinc and sulfuric acid. So we'll watch all three of these together. Maybe I'll set this on the counter so it is not so bouncy. In this one, I am not really seeing anything at all. In this one, not really either. In this one, I am seeing some bubbles forming on the surface of that metal. So if I scan on over to this one, which has been in there for a while, number 4, that zinc and magnesium sulfate, again, not doing much, nor is the copper with sulfuric acid, but you can see that the bubbling has become a little bit more vigorous. You can see some of the bubbles floating up to the top now. So it's up to you to conclude whether or not a reaction has taken place. Again, if the reaction has taken place, that means that the element that was by itself is more reactive than the element it's replacing. If a reaction does not take place, the element that's by itself is less reactive than the element it would be replacing. So now the goal with this is to rank all of those and then to continue on in the report by using your logic to rank different combinations of sets of 3 and then a little bit more elements near the end of this lab report. So I just want to peek back here at that silver nitrate. You can see those crystals are very beautiful, and that solution really has taken on a blue color. Remember, it was originally clear. It was copper in silver nitrate. And I would like to just pop back to the lead, because that's also one of my favorites. It's so sparkly and pretty. Let's go ahead and take a look at this side, the ones that I put in a little bit later. Again, very pretty silver crystals. You can see they're spiky and shiny. And what does our lead look like? Our zinc and lead nitrate look like? Ooh, so sparkly and shiny. I love it. Those are my favorite 2 reactions, which is why I'm spending a little bit more time on them. So, thanks for watching.